Okay, we're in part 2 now of section 9.4, and we're doing partial fraction decomposition. And so the first thing we notice on this one, they didn't factor the denominator for us. So that's our first thing we need to do. So let's take x squared plus 10x plus 24, and that factors into two things. And they're not going to give us something that we can't factor or we have to use the quadratic formula for. They are going to be usually nicely factorable, or you're gonna have to know perfect squares or difference of cubes or something like that. So factors of x are going to be x and x. Now they're both plus, so we know it's plus and plus. And now two factors of 24 that add to 10. Well, 4 and 6 look like they would work. That'll give us 4x plus 6x, that's 10x, that's 24. Okay, so that works. So this now becomes 5x plus 16 over x plus 4, x plus 6. Okay. So now at this point, we notice we do not have repeatable factors here. And so what we can do is we can say, well, we want a over the first factor plus b over our second factor. All right, now we're going to, this is just going to say go to that. And so now what we need to do is we need to multiply by the LCD, which is x plus 4, x plus 6. So when we multiply by the first one, we just get the 5x plus 16 on the left. Here, when we multiply, the x plus 4's cancel, so we get a times x plus 6 plus b times, now the x plus 6 cancels, so we get x plus 4. And now we have to distribute and simplify. And so 5x plus 16 equals ax plus 6a plus bx plus 4b. Now we have like terms. And so we have 5x plus 16 equals a plus bx plus 6a plus 4b. All right. So this term I'm going to compare to this one. And this one, I'm going to compare to this one. So when I do that, I have 5, because that's in front of the x, is equal to a plus b. And then I have 16 is equal to what? 6a plus 4b. Okay. So now I'm basically at the point where I have to decide what I'm going to do. And I think if I'm going to continue on with the just elimination, if I multiply by a negative 6, that's bigger, but if I multiply by the 4, that's smaller. So I think I'll multiply this by negative 4. So then I get a negative 20 equals negative 4a minus 4b. So now I can just take those two equations and I'm going to eliminate my b's. So 16 minus 20 is a minus 4. 6 minus 4 is 2a. Divide by 2. A equals a negative 2. All right, well, what does that give me for B? Well, if I plug that back in here, 5 equals a negative 2 plus B. Well, I add 2 to both sides, so B is equal to 7. All right, so that means I can put those A and B here, and I get 5x plus 16 over x plus 4, x plus 6 equals A, which I said was negative 2 over x plus 4, and then plus b, which I said was 7 over x plus 6. Okay, and that is going to be my partial fraction decomposition of the original given uh, term here. Okay, and again, the key is with this batch, we do have no repeating factors, and so we can do this in a simple manner and work through it and get our final answer. Let's do another one. All right, so this one we have 6x squared plus 25x plus 25. And so we have to think about how we can factor that, because that's our first job, is 6x squared plus 25x plus 25. Well, with the 6, we can either have 2 and 3 or 6 and 1. Usually, they try to do the middle ones. Not necessarily always, but usually. And 25, I would go with the middle ones there, 2, 5, and 5. And let's see if the plus works. So we have 2 times 3 is 6x, and then 5 times 3 is 15x. And so does that give me the 25? No, 15. Oh, sorry, I don't know what I was doing. It's 2 times 5 is 10x, sorry. I was doing the first term, which was the 6x squared, and then plus 10x plus 15x, and then plus 25. And so 10x plus 15 is 25x. So that is the correct factorization. And so then that gives me x over 2x plus 5 times 3x plus 5. And again, using the trick where you use the middle terms as one I always try first. Then after that, I'll try the first one, change it. Then after that, I'll try the last one. And so they're different terms. So again, we can just say a over our first one plus b over our second one. And now we're going to multiply by our complete LCD, which was the 2x plus 5 times 3x plus 5. So when we multiply the first term, we just get x. Now the next one, we get a times, and then the 2x plus 5's cancel, so we have 3x plus 5 plus, and then we'll have b times. Now the 3x plus 5's cancel, and we have 2x plus 5. Now we need to distribute. So that would be a times 3, so it's a 3ax. A times 5 is going to be 5a plus, here that's going to be a 2bx plus 5b. So something a little different than before. We have numbers in front of our a's with the x term and the b term here as well. And so here we have, basically it's just a designated 1. So we have 1 is equal to, we have 3a plus 2b. So I'm kind of skipping a step where I say, well, this is going to be 3a plus 2b times x plus 5a plus 5b. So that's really kind of the step right before this. So if you're kind of lost, I'm going to go ahead and put that in there. And then we have no more terms here for the numbers, and so that means 0 equals 5a plus 5b. All right. So what seems to be the best bet here? I think probably we could do substitution, or we could just eliminate. So if we stick with elimination, I'm going to try to determine which one has the smaller number I need to multiply by. Here's 5 and 3, and here's 5 and 2. So if I multiply this by, say, a -5 and this one by a +2, that's going to give me, if we go back up here so we have space, so we have the -5 and the 2. So -5 times 1 is -5. -5 times 3 is -15a. And -5 times 2 is going to be a -10b. Here we're going to have 2 times 0 is 2. 2 times 5 is 10a. And 2 times 5 is 10b. And again, there's all kinds of different things you could have taken and solved for a, plugged it into here. It really doesn't matter. All right, so we can cancel here. -5 plus 10 is going to be -5a. -5 plus 0 is -5. So that means a is equal to 1. Okay. Well, if a is 1, then we can go back over here and solve for one of these. And so we can say maybe, okay, well, if a is 1, then 3 times 1 plus 2b equals 1. And so we're going to subtract 3 here, subtract 3 here. And so 2b equals minus 2. And so b equals a -1. Okay, so I have my a and my b, and I just plug them back into the formula here. And so my decomposition looks like the original part after we factored it, of course. And then a was 1 over 2x plus 5 plus b is -1. So it's a -1 over 3x plus 5. Now you could also say, well, this is 1 over 2x plus 5 minus 1 over 3x plus 5, and bring that negative here and make it a negative in between, or you can just leave the negative up here. So either way, it will work. It's the same thing. You just depends on how you like your ones and your negatives and stuff. So that one works. All right, what about this one? Well, this is another one where we're actually going to have to do some factoring. And so what we have to think about is what two factors of 15 add to 8? Well, that would be 3 and 5, I believe. So x squared plus 8x plus 15. That's going to be x plus 3, x plus 5. So it'd be 3x plus 5x is 8x. That's 15. So that looks good. And so if we go ahead and say, okay, well, that goes to 4x plus 3 over x plus 3, x plus 5. Well, these are two different non-repeating terms, so that's going to be a over our first one, and then plus b over our second one. Now we're going to multiply the whole thing by x plus 3, x plus 5. So when we do the first one, that drops the denominator, and we just get 4x plus 3. Now when we multiply here, the x plus 3's cancel, so we're going to have a times x plus 5, and then plus b times, now the x plus 5's cancel, and we have x plus 3. Now we distribute, so we have 4x plus 3 equals ax plus 5a, plus here we have bx plus 3b, and as we've done before, we'll take out the x, and so we'll have a plus b times x, and then plus 5a plus 3b, and that's all equal to the 4x plus 3. So we have that is equal to that, and that is equal to that. So our two equations we're going to use is 4 is equal to a plus b, and the other one was 3 equals 5a plus 3b. All right. Sticking with our trend of just elimination, I'm going to multiply this one times a -3, and then I'm going to eliminate that because if I multiply by 5, that'll be bigger. So here I have a minus 12 equals -3a minus 3b. And then if I take 3 minus 12, that's minus 9. 5 minus 3 is 2a, and those cancel. And so it looks like we have our first case of fractions. So we divide by 2, and we get a is equal to a -9 over 2. Okay, so we have a fraction. That's not bad. You know, again, all we're going to do is we're going to put our fraction in the numerator, so it really doesn't matter what it is. Or if we want, we can write it down in the denominator plus the numerator. So there's two ways we can write these when we get done. And now b, how do we get that? Well, 4 is equal to a -9 over 2 plus b. So if we add 9 halves to both sides, well, we're going to have to multiply by 2 over 2 to get a common denominator. So we have 8 halves plus 9 halves. So that's going to be 17 halves is equal to b once we add and get those together. So in reality then, we have 4x plus 3 over x plus 3, x plus 5 equals, and now our a was -9 halves over x plus 3, plus b, which was 17 halves over, and then we had x plus 5. And so what we can do is we can leave it like that, or we can write it in the denominator. And so really this is going to happen is we're just going to drop that 2 to the denominator, drop that 2 to the denominator, because if you know, if we want to get rid of this, we're going to multiply by 1 over the reciprocal, 1 over the reciprocal, and that puts that x plus 3 in the denominator here. So that gives us a -9 over 2 times x plus 3 plus, and then we have 17 over 2 times x plus 5. Now I wouldn't multiply that out, I would just leave it as it is there, and then that would be my partial fraction decomposition. Or if you liked it better with the fractions only in the numerator, you know, that would be fine as well, because sometimes they'll just ask you what are a and b. All right, so that's in the part 2. I'll be back with part 3.